simple phenomena. You know, from here now, you should be able to differentiate your normal speed and your uniform speed. Speed is just the definition. Speed from that definition is just the ratio of what? Your distance with respect to what? Time. While uniform speed is a phenomenon whereby a body what? Moves at a particular what? Speed without what? Or a phenomenon whereby a body moves at a particular, from point A to point B at a constant speed. The speed does not change. So that's all about uniform speed. Another one is what? We'll be looking at the position versus time. The position versus time, that is, how do you plot a graph? You know, it's a very simple case when you're looking at speed generally. Factors or parameters that determines the speed of a particular body. We'll be looking at what? The position of that what? Body. And we'll be looking at what? The time taking. The actual what? Time taking. These are the factors that determines what the speed of a body will be like. Now, physicists now sat down to now look at it that, okay, for us to now break down what speed actually meant, for us to now look at speed in a very diagrammatical way, then let's put it in a what? In a graphical form. And that is why the position, that is the point, the location, is being plotted against time. Now, if you look at it, now on a flat plane, do you understand? This particular plane is an horizontal plane. Now, when you have a horizontal plane, now on your slide you realize that there is a particular what? Location. This particular location is for what? Your 10 meter, and this particular location is for your what? 20 meter. This is a point. This is point A, and this is what? Point B. So this is just a preamble, or this is just an intro before going into what? The actual graph. What is actually meant by what? Using graph to explain what? Speed. So you have to understand this, that when you have a plane, there's potential for the plane to be measured in terms of what? Meters. Now, before a body will move from here to here, it will definitely cover a particular time. Also, for a body to also move from here to here, it also covers a particular time. So this is just what? The horizontal explanation of what speed could be. Now, let's now go into the real diagrammatical expression, that is plotting a particular graph. Now, if you look at it, before you plot a graph, let's look at that. Now, before you're looking at a graph, there's what we call graphical table. There's what we call graphical table. Now, what is the function of the graphical table? It could be like this. Now, if you are conversant with your graph book, now your graph book, we have what we call Cartesian plane or Cartesian axis. Now, the vertical one is definitely always called the y-axis. While the horizontal one is called your what? X-axis. Now, what are you actually trying to do? For you to plot a graph, it's just like plotting points of this what? Vertical plane axis against points of what? The horizontal axis. Let me say I want to plot 0,2. Of course, in your what? In your normal elementary mathematics, you were told in geometry that the first number, you understand, this particular bracket are points with respect to what? These two plane. Now, the first number in the bracket represents the what? X-axis. While the second one represents your what? Your y-axis. So it means that this 0 now is a point on what? X-axis. Now, automatically you know that the point of intersection is always 0. So this is definitely the first point. Let's say this is A and this is B. So this is point A. Now for point B now, this is for x-axis. Now for point B, which is on the y-axis, you have to locate your what? Point 2. So this is point 2 now. So 0 to 2 now, you just trace it up here. You understand? So automatically, this is collation of A and B will give you what? A capital A. So this is the first point. Now this A is automatically a point with respect to this particular two numbers given. Are we getting it? Now, for those 2 points to actually be located, for this value to be written out, now if you are looking at a complex scenario, then you must be looking at what? A table where the 2 points will be located. Will be indicated. Now I told you that this is y-axis and this is for what? X-axis. So you represent A. The first column, you understand, the first column is always written in what? and it's always written for the x. Now the second column will go for what? The y. So here now if you're having a complex point, this is a single point, point 0, 2. This is A. I can also have point 2, 3. Point 2, 3 is telling me that what? On my x-axis, I'm looking at point 2. If this is 1, this is 2. Now, 3 means that I'm looking at what? 3 on my what? Y-axis. So this is 1, 2, 3. So I'll just trace this way, trace this way, and the point where they meet is my what? Second point, which is if I'm looking at this as what? B. Hope we are getting it now. So these are the things we need to what? Consider. This is point A, this is point B. So it's automatically becoming complex. This is first point and this is second point now. So at this junction, you must use a table. So it is that table which you now have that you now use to plot your what? Complex graph. So these are the table you must know. Now let's come back to the position and time graph. Now for you to have your position and time graph, all you just need to do is what? Change this notation. Position, let's say position is for what? Let's say x in meter, and your time, you say t in seconds. Are you getting it now? So automatically you have replaced the x-axis, ordinary x-axis is the x in terms of what? Distance, and the ordinary y-axis with t in terms of seconds. So that is just what we call the what? The graphical table, which is automatically the what? It's automatically the what? The numerical table needed to actually plot your what? Physics graph, or to actually plot your what? Geometric graph, which you will use to what? Explain a lot of things. Now, under our speed, under the speed which you are actually trying to break down, you definitely need, you must definitely know the conversation with the knowledge of graph. Now, let's look at this. Let me break one down so that you get it clearly. We have one here. The table has this. You know, it's being drawn, can be drawn any way or anyhow. All you just need to know is that how do I input the values. Now look at this one. Now, instead of drawing it horizontally, it was being drawn vertically. You still just have to know where your points are. This point is given as time in seconds, and the next point is given as what? Position, which is still my x in meter. We're giving the first point as 0, 0, the second point as 1050. The third point as 2000, meaning that this is what? 20 seconds, and this is what? 10 meters. Now the last one as 30 to what? To 150. Now if you are told to what? Expatiate this, or if you are told to explain what does this table, the table of numbers, how do you explain this? This is very easy or very simple. It's actually telling you that when the particle is on position 0, that's just spent 0 seconds. When the particle now moves to what? Position 50, that's 50 meters. The time it will take for it to move from that 0 meter to 50 meter, it will spend what? 10 seconds. Now, it gets to 50 meter, from 50 meter to 100 meter, it will spend an additional what? 20 seconds. While when it get to 150 meter, from 10 meter to 150, they spend an additional 30 meters. So in total, it will have moved, here now, it will have moved 150. You understand? Here now, all you just need to do is the cumulative of what? Your what? Time. That's summation t, which will give you what? 60 seconds. So it means that for a body to move 150 meter, you will have gone 60 seconds. Do you understand? This particular value might not be correct if the body is to move from point 0 down to 150. But if you are to look at it sequentially, that is, the first point in which it moves, you recorded it. The second point, you recorded it. At the end of the day, you will have blown 60 seconds, moving 150 meters. So that's just explanation as regards this table. So now we'll now go to the more complex one. What do I mean by the more complex one? Just wait and see. Let's move on. Now, on the other hand, the explanation of the table still continues. Now look at what the slide is saying. It says the runner is at 50 meters after 10 seconds, 100 meters after 10 seconds, which are what explained. Now the graph for that is now being drawn. Now let's move ahead. You just follow the graph. You realize that, okay, let me put that up or two for you to get it straight up. Now we said it is time against what? Distance. Irrespective of wherever your time is, your time could be here in seconds, while your distance could be here in what? In meters. Now, the values for time, oh sorry, the time is supposed to be here. Time in seconds, while your what? Distance in what? In meters. Now you label the scale for what? Y-axis with respect to meters and not another thing. Why? Because this is meter, so you label it as it increases. Let's say this is 50, this is 100, this is 150, and definitely this is what? 200. You understand? Now, if your time definitely is like this, you can label it 5, 10, 15, 20, 25. Now, from our graph there, you have 2 points. Point of 50 to 10, so you bring that one here. Are we saying it? Now, we have another one, 100 to 20. This is 20, this is 100. You can bring that one here. Cross it. Then we have 30. This is 25, so 30 should be somewhere here. 30. Now, you take your 30 upward to 150. This is 150. You can bring your 30 somewhere here. And you lock it up. So, automatically here, this is the kind of a graph which you have. Do you understand? In terms of time. Do you understand? In terms of distance per what? Per time. Now, automatically, if you look at the way at which this particular it's actually going upward. What do I mean? It's ascending. It's like something that is going up a hill. Now, this is what I want you to understand. You know, we were saying it the other time. He said, for a body to move from point A, if this is point A to point B, 2 things can take place. Point 1, this body can be moving from point A to point B, increasing its speed while it's moving. Do you understand? That's the type of what? Movement with non-uniform speed. But this body, same